Hello everyone, welcome to ITversity YouTube channel, and this is Raghu, and today we have a brand new full course on Spark SQL. If you are somebody who is comfortable with SQL and you want to leverage your skills in the big data area, then this course is right for you. Apache Spark, the big data processing engine, allows you to program using SQL. It is just like writing simple SQL queries, but it will be executed by Spark. That means your queries can process big data. So in this end-to-end tutorial, we will show you starting from scratch, absolute beginning, how to create a cluster, load the data, start writing queries, etc., etc. And this entire course is executed, or the demos are actually shown on Databricks Community Edition. So if you are somebody who is watching this video for the very first time, if you have not watched the previous videos in this particular playlist, then I request you to check out the first video in this playlist, which will help you to create a free account with Databricks Community Edition so that you can practice Spark absolutely free. So once you have a Databricks Community Edition, then you can come to this video, and we have all the resources, notebooks available in the description. You can take it and start practicing right away. And if you look at what we cover in this course, we start by identifying the dataset. So Databricks already provides a lot of real good datasets for us to practice. So we will pick up an online retail dataset, and then we will see how to create external tables in Spark SQL. Then how can you connect your data with the table? Then we start slowly writing and understanding queries. For example, you have grouping queries, aggregations, filters. So we will be covering all these data manipulation tasks in Spark using Spark SQL. And we will be even covering the entire end-to-end sort of like a data engineering pipeline. Towards the end of this particular course, you will learn enough knowledge to combine all the different pieces that you have learned in this course and create a data engineering pipeline. So I don't want to give you I don't want to break the surprise. I don't want to walk you through everything that we are going to cover in this course, but rest assured, if you watch the complete course, you will gain enough confidence to directly start working with a Databricks cluster using SQL. If you are somebody who has not subscribed to our ITversity YouTube channel, then please consider doing so, and watch out this space for more tech-related content. We at ITversity are committed to publish a world-class tech content on a weekly basis. You can see a lot of content coming from us on a weekly basis. And if you check out this particular playlist, then you will see that every week we update this playlist. We have tutorials, and we have hands-on exercises, we have concepts, everything related to Spark and data engineering inside right within this playlist. And check out our channel for a lot of content related to data engineering, Gen AI, and whatnot. Now, in case if you're somebody who want to learn the basics of SQL and obviously to learn Spark SQL after that, then I will pin one of our very popular Udemy course in the description. Check it out, where you can learn SQL from absolutely scratch and then build your confidence. So without further delay, let's get started.
Let us see how to get started with the Databricks Community Edition to learn Spark SQL. Keep in mind, you need to have valid account in Databricks Community Edition. If you don't have the account and if you need some help, make sure you see the description. There is a video about how to get started with Databricks Community Edition. I would highly recommend you to go through it and then have the account, then come back here. To come back here, the link is nothing but this one. We'll also provide this link as part of the description. Once you are here, you have to enter the email ID using which you have signed up for the Databricks Community Edition along with the password. Then you have to click on sign in. In my case, you can see the email and also password. Now I should be able to click on sign in to get into Databricks Community Edition using my account. In case if you are running into any challenges, feel free to reach out to us. We will be there to support you. That being said, you can see the notification here. It is saying you are using Databricks Community Edition, upgrade for unlimited clusters and collaboration features. That being said, don't worry too much about this. The Community Edition is more than enough to learn basics or essential skills with respect to Spark SQL. Once you are here, you need to make sure you go to compute. You can move your mouse onto this and then click on compute. Then it will take you to the compute. You need to ensure the cluster is up and running. If the cluster is terminated, then you have to clone and then rename the cluster. Also, you can delete the terminated cluster. Once you rename, you should be able to click on create compute, then the cluster will be created. This is one of the limitations with respect to Databricks commutation, but it is not a tough limitation to overcome to learn Spark SQL. That being said, make sure your cluster is up and running. Then you can actually go to new here, then click on notebook. Here you need to make sure you select SQL. By default, it might be Python for you. You just have to click on this drop down and then click on SQL. Then it will choose SQL as language for this notebook. You can also rename this notebook by saying getting started with Spark SQL. Now the notebook is renamed. To ensure this notebook runs without any challenges, you need to make sure the cluster which is started is selected here. If not, you just have to click on this and then choose the appropriate cluster. Once the cluster is selected, then you should be able to run this command. Select, then current database. This will just confirm whether you are able to run SQL commands in this environment or not. You can see the current database is nothing but default. This is how you can actually get started with Spark SQL using Databricks Community Edition. Keep in mind the prerequisite is you need to have valid account with respect to Databricks Community Edition. If not, you have to sign up and then you have to make sure the cluster is up and running. Then you can start with a notebook like this and then start running SQL queries like this. Now let's review the datasets which we are going to use to learn Spark SQL in this Databricks Community Edition. When it comes to reviewing the datasets, you should be able to use something called as %fs. %fs is one of the magic commands which you can use in a Databricks environment. This command is primarily to interact with the file system. That being said, Databricks itself provides a lot of free datasets. You should be able to access them using DBFS protocol. To begin with, you have to start with this command, %fs. Keep in mind, fs stands for file system. Then ls. Then you have to say dbfs:/Databricks -datasets. This is the base folder. This has several subfolders. Let's run this. Let's review the details and then we'll take it forward. It is currently running. It will take a bit of time. Now you see there are quite a few subfolders in this. For this course, we will primarily use online retail. Let me scroll down. You can see the path here. Let me copy this. Now let me run %fs ls on this path. This online retail have one more subfolder. The subfolder is nothing but data-001. This is where we have files. We have one file. Let's review that as well. Here we just have to specify this name after the folder. The name is nothing but data-001. It is also a folder. You can see there is a file called as data.csv. Using this, we should be able to learn Spark SQL. Now it is time for us to understand the characteristics of this dataset. For that purpose, we have to use a command called as %fs head. Let me copy paste this enter command. Let me replace ls with head. Now let me say data.csv. Now let me run this. We should be able to see first few records. You can see first few records here. There are quite a few of them. It have actually displayed 64 KB of data. If you observe, the first line contain column names. The column names are nothing but invoice number, stock code, description, quantity, invoice date, unit price, customer ID, country. Also, both the header as well as the actual records in the CSV file have values separated by comma. You can see here, this is invoice number, then comma, then stock code. So the actual values with respect to each of the columns are separated by comma. This is how data is structured in this CSV file. It is very, very important for us to understand this. Now, as we have spent time in going through FS commands and also spent time in reviewing the data, it is time for us to come up with external table pointing to this location. Let's get into the details about how to create external table pointing to this location. Then we will see how to process the data. Once we go through the details about how to process the data, we'll also see how to write the processed data back to DBFS or Databricks. So far, we have seen how to get started with Spark SQL using Databricks Community Edition, and also we have reviewed the data which is related to online retail. Now it is time for us to get into the details about creating external table pointing to this location. The location is nothing but this one. Also with respect to the data, it contain header. This is the header. Then the file have quite a few records. Each record have values related to multiple columns, and each of these values are actually separated by comma. You can see the delimiter here. You have to keep these details in mind before getting into the details with respect to creating external table against this location. First, let me copy this location. Then let me go here. Let me say create external table. Then table name, let me say online_retail. You can give the name of your choice. In my case, I am naming it as online_retail. Then as the CSV file have header, we don't need to specify any columns and data types. They will be determined automatically if you use appropriate options. How to specify the details with respect to path and options, we will get into the details very soon. After coming up with this piece of code, you have to use using. As part of using clause, depending upon the file format, you have to specify CSV or JSON or Parquet or any other format that is supported. In this case, our data is in CSV format, hence we should be able to say CSV like this. Then we have to use options. As part of options, you have to specify the path, the delimiter if it is applicable. Also, if you wanted to infer the schema based on the data, you can use options such as infer schema as well. First, we'll start with path. Already I have copied the path. I just have to paste. Let me specify the path here. After this, I have to say comma. Then I have to say header equal to true. After header equal to true, I also wanted to say infer schema equal to true. After specifying all the options like these, you should be able to run it. It will take care of creating the table for us. Now we should be able to say show tables. We should see online retail as one of the tables. Let me specify tables in uppercase. You can see the tables here. One of the tables is nothing but online retail. If you wanted to review the columns associated with this table, you just have to use describe command. Let's say describe, then online retail. Let me run this. You should be able to get the details about columns and data types. Keep in mind, it is because of these options such as header equal to true and infer schema equal to true. It have gone through the details in the file. It have inferred the data types based on the data, and also it have inferred the columns based on the header in the file. This is how you should be able to quickly create external table when data is in CSV format with a header, and also you should be able to use infer schema to infer data types of each and every column. In case if the delimiter is anything other than comma, you have to even use additional options. But for comma, you can skip additional options to specify the delimiter. Now, let's also review the data to confirm whether data is being retrieved as per the expectations or not. Keep in mind, we have created external table pointing to existing location. It will be able to interpret the data and show us when we run appropriate commands. In this case, I'll be running the command select star from. The table name is nothing but online retail. Let me say online retail. Now let me run this. Let's review the outcome. You can see the outcome here. The data is as per the expectations. You can also use this query, select count of star from online retail. Then if you run it, you should be able to get the count. That being said, as we are able to successfully create the table pointing to location where we have CSV files, now it is time for us to get into the details about how to come up with queries to process the data based on the requirements. Also, eventually, we will see how to write the processed data into Databricks again using SQL itself. Now, let me review the data here and come up with a few problem statements so that we practice Spark SQL in our learning process. If you observe, this table called as online_retail have several columns. They are nothing but invoice number, stock code, description, quantity, invoice date, then unit price. On top of unit price, we also have additional columns. They are nothing but customer ID and country. Now, if you look at the records here, we have multiple records for each invoice number. You can see here for 536365, there are 7 invoices. It means invoice number alone is not unique. you have to combine with other columns if you want to determine uniqueness in this dataset. Don't worry too much about the unique combination of columns. We will not be spending too much time around it. Let's get into the problem statements. If you observe further, we have quantity and unit price. However, we do not have the subtotal for each item. Keep in mind, for each invoice, we have items. In this case, this data represents invoice items, not just invoice. That's why for invoice 536365, we have 7 records, which means we have 7 items. For each item, we have quantity and unit price. If you want to get item level subtotal, then we have to multiply quantity and unit price. On top of it, if you want to compute revenue by invoice or by date or by customer ID, once we compute item level subtotal, using that we should be able to compute invoice level revenue or revenue by date or revenue by customer ID. We'll get into the solutions for these problem statements. In that process, we'll actually practice Spark SQL. Yeah, we have understood the data. Now it is time for us to compute item level subtotal. I'll be calling it as the item revenue. Let me come up with the query, then we'll take it forward. Here I have to say select, then t dot star. T will be alias for the table. Let me first say from, then online underscore retail. Let's run this. It is failing because I haven't specified the alias for the table. Let me say add t. Now it will run without any issues. You can see the outcome. On top of all the existing columns, I also wanted to add one more column. However, it is a derived column. Here, the derived column name is nothing but item revenue. The formula is multiplying quantity and unit price. Now let me say comma, then quantity multiplied by unit price. You can provide alias to the derived fields using as like this. Let me say item revenue. Now let me run this. We should be able to see the details as per the expectations. However, if you observe item revenue, when it comes to decimals, there are too many instead of just 2 or 3. I would like to round off these to 2 decimals. For that purpose, we should be able to use a function called as round. Round is a predefined function within Spark SQL. In case if you wanted to list all the functions in Spark SQL, you just have to say show functions. Once you run show functions, you should be able to see all the expressions as well as the functions, or operators as well as the functions. In this case, we are going to use round. Let me scroll down all the way till R to review round. You should be able to see round now. You can see round. In case if you wanted to get the syntax with respect to round function, you should be able to use something called as describe function. Let me say describe, then function round. You should be able to see the syntax of it. It takes the expression followed by number of decimals. The expression is nothing but this one. Let's make sure we enclose in circular brackets. Then let's make sure we use round function here. We also need to pass second argument. The second argument is nothing but number of decimals, which is nothing but 2. Now let's run this. This time you should be able to see item revenue with 2 decimals. Let me scroll towards right. You can see the outcome. At max, it have 2 decimals, not more than that. This is how you should be able to perform row level transformations using Spark SQL. In this case, we have used formula to multiply quantity and unit price to compute item revenue. On top of it, we ended up using round function to round the result to 2 decimals. This is how you should be able to start learning Spark SQL using Databricks Community Edition. As we are able to compute item level revenue, now it is time for us to explore invoice level revenue. As we are able to compute item level revenue, now let's use this derived column and let's compute invoice level revenue. For that, we have to group the data by invoice number. Then we have to use the aggregate function called as sum. Using group by with the aggregate function sum, we should be able to compute invoice level revenue. Now let me scroll down here. I'll actually copy this first, then paste here. Here I'll not be displaying all the columns. I'll be using only invoice number. Hence I have to say t dot invoice number. Then I should be able to say round. Then I should be able to pass this expression with number of decimals so that we compute item level revenue as well. Using this item level revenue, we need to compute invoice level revenue. For that purpose, we have to actually say sum. Then we have to pass this round of quantity times unit price with 2 decimals to sum. Let's rename this as invoice revenue, because now it is not item revenue anymore, it is invoice level revenue. After from clause with the table with alias, you have to use group by. Let me line break here. Also, let me line break here. This is primarily for readability purpose. Now, let me say group by. As part of group by, I should be able to say t dot invoice number. Now, let's run this. We should be able to see the invoice level revenue. You can see the outcome here. However, the data is not rounded off to 2 decimals. It is recommended to move round to here. So you have to pass sum to the round function so that the decimals are rounded properly. This is the correct logic, and here we have to close this bracket. Then we have to clean up this bracket. You need to make sure the syntax is right. First, we are multiplying quantity with the unit price. After multiplying the quantity with the unit price, we are actually passing the result to sum. It will aggregate the data per invoice. However, it is not rounding off to 2 decimals. The aggregated data is being passed to round as first argument, and then we are passing 2 as second argument, so that the aggregated revenue per invoice is rounded off to 2 decimals. Make sure you also come up with logic in the similar fashion. Now let's run this. This time the result will be as per the expectations. In case if you wanted to sort the data in descending order by invoice revenue, then you should be able to say order by here, then invoice revenue, t dot invoice revenue. We should not be saying T, because invoice revenue is not part of online retail. It is a derived column. Here we have to say invoice revenue, or we can also use positional notation, which is nothing but 2, because it is second column. Even if you say 2, it will work as per the expectations, but I would like to specify the column name like this, or alias name like this. This is not column name, this is alias. Now let me run this. You should be able to see the outcome as per the expectations. In this case, data is sorted in ascending order. I would like to sort the data in descending order by invoice revenue. Hence, I would like to say DESC here. This will ensure data is sorted in descending order. The default is ASC, which means ascending order. However, it makes sense to see the data in descending order by invoice revenue. Hence, I have changed it to DESC here. Now, on top of this, I also wanted to see number of items in each invoice, and also total quantity per invoice. For that purpose, I should be able to add additional aggregate fields like this. The first one is count of t dot invoice number. When it comes to alias, let me say item count. Then sum of t dot quantity. When it comes to alias for this, I'll give the name as invoice quantity. Now let's run this. On top of invoice revenue, we should be able to see item count as well as invoice quantity. This is how you should be able to come up with queries using group by and aggregate functions to aggregate the results.
If you like the video so far or the tutorial so far, then consider clicking on the like button and share it with your friends who might benefit by watching this tutorial. Also, pour in your valuable comments and do let us know what are the topics you want us to come up with content on. So you can suggest the topics of your interest, and we will make sure that we come up with proper content and publish it in our channel. Let's continue with the course.
In the process of learning Spark SQL using Databricks Community Edition, we have come up with quite a few Spark SQL queries. Now it is time for us to recap different clauses which we typically have in SQL. We'll also go to the details about the order in which we typically write the SQL. After that, we'll also go to the details about in which order the queries will be executed. That being said, Spark SQL also follows something called as the ANSI syntax. Any popular RDBMS or any database which supports SQL follows ANSI. If you are familiar about SQL using databases like Oracle, Redshift, Postgres, etc., you should be able to write Spark SQL queries with ease, because when it comes to the syntax, it is same as ANSI. Let's recap different clauses which we typically use in SQL queries. The same clauses are applicable even with Spark SQL. The clauses are nothing but select, then from. If you wanted to join multiple tables, you also use join. When it comes to join, it can be inner join or left outer join or right outer join or full outer join. When we use join, we also use something called as on clause. So after from, if you wanted to join multiple tables, you use join, one of the joins. Whenever we use one of the joins, we also have on clause. Then with respect to aggregations, we use group by clause. Also, we use order by clause to sort the data. So these are the clauses which we typically use with respect to SQL, not only just Spark SQL, with any SQL. When it comes to writing order, first we start with the select clause. We specify all the columns and expressions in the select clause. So this will be the starting point. Then we specify the from clause. As part of from clause, we specify one or more tables. If you have more than one tables, then we use join as well. When it comes to join, it can be inner join or outer join. When we use join, we also might use on clause. So after join with the on clause, then we specify where clause. I forgot to mention about where clause. Keep in mind, after join with the on, we typically use where clause. After where clause, we specify the group by clause. So considering join as third, on as fourth, and where as fifth, group by can be specified as 6 here. As part of group by, if you wanted to filter data based on the aggregated results, we also use having clause. It will go 7th. Then finally, we'll have order by, which is nothing but 8. So with respect to order, when it comes to writing queries, the first one is nothing but select clause, then from clause, then join with on, then where, then group by, then having, then order by. But when it comes to execution, the order is different. It will not start with executing whatever you have in select clause. It actually starts with from clause. So from will be executed first. If you have more than one tables in from, then you'll have join. Join will be executed along with the on clause. That will be executed next. After that, the filtering happens because of where clause, if you have where clause. So when it comes to order of execution, second one will be join. The third one will be on clause, which is part of join itself. The fourth one will be where to filter the data. Then fifth one will be group by. If you have having within group by, then sixth one will be having. After executing whatever you have in group by and having, it will take care of executing whatever you have in select clause. So seventh will be select. Then finally, it will sort the data. When it comes to order of execution, the last one is nothing but order by, which takes care of sorting. So there is a difference with respect to the order in which we write the queries and also the order in which the queries are executed. Why it is important for you to understand? Whatever aliases you mention in a select clause, those aliases will not work in a where clause, but they will work in order by, because order by will be executed after whatever is there in select clause. Before that, it will not be executed. That's why it will work. With respect to group by and having, in Spark SQL it works, but in other databases it will not work. You have to specify the actual columns in the table and expressions around the tables in group by and having. You will not be able to use the numbers. But in Spark SQL, as part of the group by also, you can specify the numbers when it comes to the columns which you wanted to use as part of group by. So in this case, even if I say 1, because we wanted to group the data by invoice number, it will work. Keep in mind, as part of group by, we will not be able to use the derived fields, especially when aggregation is involved. So if you say 2 or 3 or 4, it will not work, but 1 will work. With respect to other databases, specifying the column aliases as part of group by will not work. Now let me run this. Let's review the outcome. You can see the outcome. It is as per the expectations. Here, either we can specify the column name or the position of the column. As long as it is the typical column without any aggregations, it will work without any issues. Now, as we have gone through the details about the order in which we are supposed to write the queries and also the order in which queries will be executed. Now, to make sure we are quite comfortable with the Spark SQL, let's also get into the other features with respect to Spark SQL, which are similar to whatever we know with respect to any SQL. Once we go through those details, towards the end, we'll actually talk about how to write the processed data into new set of tables. The tables will be created as part of Databricks platform itself. In the process of learning Spark SQL using Databricks Community Edition, we have explored quite a few details. We have written quite a few queries, and also we have revisited the syntax with respect to SQL. Now it is time for us to explore other objects which can be created in Spark. They are nothing but views and also something called as CTEs. CTEs stands for Common Table Expressions. You might already be familiar about these. However, it is important for you to review because we use these quite extensively with respect to Spark SQL or Databricks. That being said, let's start with the views. I would like to create a view for this. I should be able to copy this. Let me first clean up all the comments so that it will not cause any confusion at a later point in time. It will just take a moment. I am cleaning up all the comments here. When it comes to the syntax with respect to the view, it will be like this. You can say create, then or replace view. The name I will be giving is nothing but invoice underscore revenue underscore v, then as. Now let me run this. It will take care of creating the view for us. We should be able to review the objects by saying show tables. Show tables will also list views. You can see there's a view by name invoice underscore revenue underscore v. In case if you want to get details about the view, you should be able to say describe, then formatted, then view name, which is nothing but this one. It will give you the complete details about the view. You can scroll down and you can see even the query that is part of the view. Keep in mind, view doesn't have any data, it only have the logic. When it comes to external table, it doesn't have any logic. It have only the details about the path where we have the data. That being said, as view is successfully created and as we have reviewed the details with respect to view, now let's run queries against the view. We should be able to say select star from, the view name is nothing but invoice underscore revenue underscore v. You should be able to see the results with respect to this query here. This is how you should be able to run queries against the view. Whatever logic that is there as part of the view, that logic will be executed. Now, instead of using views, if you wanted to use common table expressions, then you have to use something called as with clause and take it forward. Also, when it comes to Spark SQL, it not only supports regular views, it also supports temporary view. The difference is the temporary view will be gone once the session is closed. Again, you have to create and then take it forward. But if you don't specify temporary while creating the view, that means the view is permanent. It will be there even when you restart the cluster. Yeah, we have gone through the details with respect to views. Now let's also get into the details with respect to CTE. When it comes to syntax related to CTE, it will be something like this. First, let me copy the logic here. I'll be creating CTE for this only. You have to start with clause. As part of the with clause, you can specify the name. Let me say invoice underscore revenue underscore CTE. Then you have to use as. Then in brackets, you have to specify the logic. And this is how you should be able to come up with CTE. CTE stands for common table expression. Typically in CTEs, we will not be having order by clause. Hence, let me delete this. Now to use this CTE, I have to say select, then star from CTE. So CTE is also similar to view. However, it is related to that query only. If you go to the next query, that CTE will not be accessible. But view, it will be there as part of that session if it is temporary view. If it is a permanent view, even if you restart the cluster, the view will be there. That being said, now let's run this. You should be able to see the outcome. In case if you wanted to sort the data by invoice revenue, on top of select star from invoice revenue underscore CTE, you can say order by, then invoice revenue. The data will be sorted in ascending order by invoice revenue in this case. However, I would like to sort the data in descending order by invoice revenue. For that purpose, I have to use DESC like this. This is how you should be able to create CTEs and then validate. That being said, as we have gone through the details with respect to views and CTEs, now it is time for us to write this data into a target table. First, we'll create a target table. Then we'll come up with required logic to populate the target table. As we have gone through the details about how to process the data using Spark SQL, now it is time for us to understand how to load this processed data into Databricks tables. First, we'll go through the details about creating table to store the data which is going to be returned by this query. Then we will see how to populate data into the table using appropriate query. That being said, when it comes to the columns in the tables which we are going to create, we should have invoice number, then invoice revenue, then item count and invoice quantity. There should be 4 columns. Invoice number is supposed to be of type integer. Invoice revenue is supposed to be of type double or float. When it comes to item count and invoice quantity, they are supposed to be of type integer. Now, let's come up with the create table statement. When it comes to creating tables in Spark, you need to ensure you specify the file format. The default is, I think, Delta, but we'll be using a Parquet file format. Databricks support several file formats. They are nothing but CSV, JSON, Parquet, Delta. On top of these things, you can also use some third-party file formats. That being said, when it comes to the syntax with respect to creating a table when data doesn't exist, it is supposed to be like this. Create, then a table name. The table name is nothing but invoice revenue. Then the first column is nothing but invoice number. It is of type integer. Second column is nothing but invoice revenue. It is of type double. You can also define it as float, but double is more relevant. Then we have to specify other columns, which are nothing but item count. It is of type integer. Then finally, item or invoice quantity, which is also of type integer. After specifying columns and data types like this, after the bracket, you have to specify using clause. As part of the using clause, you should specify the format using which you wanted to create the table. The default is Delta if you don't specify using clause. In this case, we wanted to create table using Parquet format. For that purpose, we can specify Parquet like this. In case if you wanted to use CSV, you can say CSV. If you wanted to use JSON, you can say JSON. In the similar fashion, you can specify any supported file format here. When it comes to Spark, it supports two types of tables. The two types are nothing but external and managed tables. When it comes to external tables, we use options with path. As part of path, we specify the location. It will automatically become external table. If you don't have path within options, it will become managed table. Whatever table we have created earlier, the table name is nothing but online retail. It is external table. Let me scroll up to the syntax here. You can see here, this is the syntax. We are using path and we are specifying the location. Whether you specify external or not, this will automatically be external table. As we do not have path in the new table which we are going to create, it will be managed table. Now let me run this. Let's see whether the table will be created or not. It is taking a bit of time to run. Let's wait until it is fully run. Now it is fully run. You can see the table is created as per the expectations. Let's review whether the table is created or not by using show tables command. On top of online retail, you should be able to see invoice revenue also. However, we are not seeing online retail table because we are using community edition. I think the meta store is gone. To ensure the notebook work, first we need to make sure the external table is also created. Let me scroll up here. Let me go to create table statement. This is what is create table statement with respect to online retail. Let me run this. You can see that it ran successfully. Now let me scroll down completely. Then let me run show tables command once again. This time we should be able to see two tables. One is online retail, second one is invoice revenue. Now to see the characteristics of the table, you can use describe formatted command. Let me say describe, then formatted, then table name online retail. If you look at the outcome here, there is something called as a table type. You can see here the name is type, the value is external. It means this is external table. However, when it comes to the other table, which is nothing but invoice revenue, the table type will be managed. Let me actually say describe, then formatted, then table name. The table name is nothing but invoice revenue. If you look at the outcome, if you go to type, you will see managed. In case if you wanted to review the location for this, you should be able to scroll down further. You can see the location here. The default location for default database is nothing but user hive warehouse. Underneath it, it will have a folder with the table name. You can see here, you have table name in the path. It means this is related to the table which we have just created. This is how you should be able to create tables using a specific format. In this case, we have two tables. One is external table. The other one is managed table. We also have the query ready to compute invoice revenue, item count, and invoice quantity along with invoice number. We just have to run that query using insert statement so that data which is processed is populated into the new table, which is nothing but invoice revenue. The query which we are going to use is nothing but this one. Let's get into the details about how to come up with insert statement to populate the results of this query into newly created table. As of now, we are ready with both the tables. The tables which we have created are nothing but online retail and invoice revenue. Also, we are ready with the query which have the logic to compute invoice revenue, item count, and invoice quantity for each invoice. Let me copy this logic. I am skipping order by. I'll be storing the data without ordering on any field. Also, you can review the tables that are created. They are nothing but invoice revenue and online retail. Online retail is the external table pointing to our CSV data. Invoice revenue is a newly created table. As of now, it is empty. Now, let me scroll down. Let me paste the query here. Let me clean this up. First, let's make sure we validate the query to see if the query is running as per the expectations or not. Then we'll improvise on top of it to convert this to insert statement. Now, let me run this. You see the query is running. Once it is run, we should be able to see the outcome. You can see the outcome here. The query is going to return 2,888 rows. And you can see it is returning invoice number, invoice revenue, item count, and invoice quantity. To insert these results into the table, here we have to improvise by adding insert statement before select. For that, we just have to hit enter. Then we have to go to the beginning of the above line. Then we have to say insert. After insert, depending upon your need, either you have to say overwrite or into. If you say overwrite, the existing table will be overwritten. Whatever data you have in that target location, the data will be removed, and then the new results which are returned by the query will be populated into the table. If you use into, it will just append by adding new files under the location which is created when the table is created. In this case, I'll be using overwrite. Let me say overwrite. You can also use into if you want to append. Then you have to specify table, then table name. In this case, the target table is nothing but invoice underscore revenue. This is how you should be able to come up with the insert statement to override the existing data while populating the new results which are returned by this query. Now, let me run this. It will take a bit of time to run and the data will be populated into the target table. However, the insert statement have failed. You can see the details here. It is saying cannot write incompatible data for the table Spark catalog.default. Then the table name is nothing but invoice revenue. It is also saying cannot safely cast invoice number which is of type string to int. It is because there are some string values also with respect to invoice number. However, when we define the table, we have used integer for invoice number. That's why it have failed. To fix this, first we need to make sure the table is dropped. Let's scroll up here. Let's drop the table. I can say drop, then table, invoice revenue. Let me run this. Now the table is dropped. This time before creating the table, let's change the invoice number data type to string. Now let's run this. Let's see whether the table will be successfully created or not. It is successfully created. You can validate by using this describe formatted command. This time invoice number should be of type string. You can see it is of type string. As we have fixed the issue related to the data type, now let's run this to see if data will be successfully populated into the target table or not. It will take a bit of time to run and populate the data. Let's wait until it is fully run. Then we will validate to see if the table is successfully populated or not. You can see the insert is successful. Now it is time for us to validate whether the data is populated into the table as per the expectations or not. First, I'll validate the location to see whether files are there in that location or not. Then I'll run a couple of queries to confirm whether data is as per the expectations or not. To validate the location, we have to review the outcome of describe formatted command, which is nothing but this one. Let me scroll down here. The location is nothing but this one. Let's make sure we copy this. Then we should be able to use %fs_ls command. Let's run this. It is successfully run. You can see the outcome. There are files which ends with snappy and parquet. You can scroll towards right and check the file name. This is the name of the file. You can see the extension is nothing but snappy.parquet, which means the file is of type parquet. Also, it is compressed using something called as snappy algorithm. Don't worry too much about those details at this time. Just move forward and run a couple of queries to ensure data in the target table is populated as per the expectations. The first query which I'm going to run is nothing but count query. Let me say select count of star from invoice revenue. Then let's make sure it is successfully run. You can see the count. The count is nothing but 2,888 records. Let's also preview some data. For that purpose, we should be able to say select star from invoice revenue. In this case, I'll be sorting the data in descending order by invoice revenue. For that purpose, I just have to say select star from invoice underscore revenue order by the column name with respect to invoice revenue is nothing but this one. It is in camel case, there is no underscore. You just have to specify the column like this. Then you have to use DESE to sort the data in descending order. Now let's make sure this is run. It have ran successfully. You can see the outcome. The outcome is as per the expectations. When it comes to data, the data is sorted in descending order by invoice revenue. This is how you should be able to validate to see if the data is populated into the target tables or not. Yes, we have gone through quite a few important details using Spark SQL in the process of learning Spark SQL. Let's also see how we can use this knowledge to deploy the end-to-end process as a single notebook. Yes, we have learned quite a few details with respect to Spark SQL. Now it is time for us to come up with a single notebook which takes care of processing the data end-to-end. When I say end-to-end, I'm talking about reading the data in the files in the data lake, then process the data. Once the data is processed, then writing the processed data into target tables within data lake. We should be able to use Spark SQL for all the purposes. Let me create a new notebook. For that, I should be able to say file, then new notebook. It have opened another tab. Let's first rename the notebook. In this case, I'll be saying compute invoice metrics. The reason why I'm saying compute invoice metrics is because I'm not only computing invoice revenue, I'm also computing item count and also invoice quantity. For that reason, I'm naming this as compute invoice metrics. Instead of using default database, I wanted to create a new database. The way you can create a new database is like this. Create database if not exists. That way, if database doesn't exist, it will create the database. If database does exist, it will just ignore. In this case, I would like to name the database as retail_db. Let me say retail_db. Once you run this command, it will take care of creating the database for us. You should be able to validate by saying show databases. It will list all the databases that are out there. There will be one database which is nothing but default. It will be there always. Then you can see the new database which is nothing but retail_db. However, I would like to run this as a complete notebook. We should not be having these commands unless it is absolutely necessary. Now let me clean this up. I should be able to click on this to delete this cell. I just have to confirm. I can also select this so that I'm not prompted like this again and again when I attempt to delete the cells. Now the cell is deleted. As the database is successfully created, we need to switch to the database. Before switching to the database, in case if you wanted to confirm to which database you are connected to or attached to, you should be able to use this command. Select current underscore database. As of now, we are attached to default database. However, we wanted to connect to online retail database or retail_db database. Hence, we should be using a command called as use, then retail_db. Now we are switched to retail_db database. You should be able to run select current database once again. You can see the outcome. This time it is saying retail_db. As we are connected to this database, now we should be able to create the table in this database. The table name is nothing but online retail. The location is nothing but this one. Let me go to recent here or recents. Then let me go to getting started with Spark SQL. The location where we have the required dataset is nothing but this one. Let me copy this. Now let me again go to the other notebook, which is nothing but compute invoice metrics. Now we should be able to say create table if not exists. This is going to be actional table. Even though it is optional, I would like to specify this. Let me say create actional table if not exists. The table name is nothing but online retail. As we have column names in header of the file, we can directly say using CSV. Then we have to specify options. Then within options, we have to specify path like this. On top of path, we also need to say header equal to true and also infer schema equal to true. Now let's run this. It will take care of creating the table for us. Once the table is created, we should validate by saying select star from online retail. I'll only run this query. I'll not be running describe formatted or count. I just wanted to make sure it is returning some results. You can see it is returning the results as per the expectations. Once again, I'm reiterating, I'm coming up with these commands just to validate. These are not supposed to be there in the notebook where we wanted to process the data end to end. Hence, let me delete this. As it is deleted, now let's go back to the other notebook, which is nothing but this one, getting started with Spark SQL. It is time for us to create the managed table by name invoice revenue. I'll actually name it as invoice metrics. Let me scroll down. I have to use the create table statement where I have created Parquet formatted table. The table statement is nothing but this one. Let me copy this. Now let me go back to recents and then go to compute invoice metrics. Here let me paste that create table statement. Let's run this. It is successfully run. However, I would like to add if not exists here also. That way, if the table exists, it will just ignore. If table doesn't exist, it will create. Here you can run it again. Yeah, the table already exists. It will just be ignored. It will not throw any errors. Now let's validate to see if both the tables are created as per the expectations or not. For that purpose, we can say show tables. Now let's run this. You can see both the tables. Now it is time for us to use the insert statement to populate the data into the target table by querying from online retail table. Again, let me go to recents here. Let me go to getting started with Spark SQL. Let me scroll down completely. Towards the end, we have the required insert statement. It is nothing but this one. Always I'll be overwriting. This is one of the common practice when it comes to developing the pipelines. But in some cases, we also use append process. But for now, we'll just use overwrite. Now, this is copied. Let me go back to the other notebook, which is nothing but compute invoice metrics. Let me paste here. Let me run this. It will run as per the expectations. Once it is run, we will validate by running this query. Select star from invoice revenue. That way we should be able to preview the data in the table. On top of it, I also want to run count query. These I'll keep. That way, once the data is populated, when we run the notebook, it will also run these queries to confirm whether data is actually populated or not. Let me change this to count of star from invoice revenue. Now, let me run this and we should be able to see the outcome as per the expectations. This is how you can actually come up with end-to-end logic within single notebook. Now, using any external orchestration tool or even Databricks jobs or workflows, you should be able to schedule this and run as per your schedule. Also, you should be able to click on run all to see if everything will run as per the expectations or not. You see, it is running as per the expectations. Everything is run. If you want, you can clear all the outputs. The way you can clear all the outputs is probably by going to view. Let me see if we have clear all outputs here. There is no clear all outputs here. Let me go to run. Yeah, under run, you can see clear. You can see clear all cell outputs. Now everything is cleared. You can see there are no outputs with respect to the cell executions. We should be able to click on run all. You can see all the cells have ran without any issues. Also, towards the end, you can see the data in the target table where we have copied the processed data. Now, as I have mentioned earlier, using this notebook, we can schedule either by using external scheduling tools or even Databricks jobs and workflows. This is how you should be able to come up with end-to-end logic within a single notebook. Now, this notebook is nothing but one single data engineering application where it have read the data from CSV files, then process the data to compute required metrics, and then copied data into the target table. In this case, I wanted to rename this table. I do not like invoice revenue for this. Let me name this as invoice metrics. Before doing that, let me first drop this table. Let me say drop table, then invoice revenue. Now the table is dropped. Again, I don't want to run this command again and again. Here, I just want to replace this to invoice underscore metrics. In the similar fashion, we have to rename invoice revenue to invoice metrics in all the places where we have mentioned invoice revenue earlier. Already I have done that. As we made required changes, now we should be able to go to run, then clear all cell outputs, then click on run all. Let's see whether all the cells will be executed as per the expectations or not. This is how we should be able to come up with Spark SQL based data engineering applications within Databricks platform.
Congratulations on completing this entire tutorial on Spark SQL on Databricks. I hope you really enjoy the course. Like I said before, consider subscribing to our ITversity YouTube channel and click on the bell icon so that you will be notified whenever we upload any tech content to this channel. And watch out this space for more videos related to Spark on Databricks. I'll see you in another brand new video. Thank you.